Hey y'all, in this video we're going to be naming with polyatomic ions. This is activities 8 and 9 in your practice packet. Here we're going to write the names and formulas of following ionic compounds as a warm-up. So here we have tin 4 chloride. Tin 4 means I have a tin with a +4 charge. Chlorine always has a -1 charge because it's not a transition metal. And so that means the formula of this is SnCl4. Next I have tin 4 sulfide, again a tin with a +4 charge, a sulfur with a -2 charge. So that means when I do the crossover method, I would do something like this, which simplifies into SnS2. Next, I have CaF2. I'm just going to write the name of this. I don't have a transition metal here, so I don't need any Roman numerals, so I'll just name this calcium fluoride, very simply. Next, I have Fe2O3, where I do have a transition metal, and so I have to kind of imagine the crossover method in reverse, where the charges became the amounts. Since there's 3 oxygens, that must mean my iron charge is 3, so this is iron 3 oxide. That's a little bit of a reminder on the transition metals. Now we're going to be working with polyatomic ions. A polyatomic ion is when one of your ions is not a single atom, but instead it's a group of covalently bonded atoms that called a polyatomic ion that acts like a single atom. So poly means multiple, atomic obviously refers to the atom, so polyatomic means you have multiple atoms. A list of the most common polyatomic ions is found on the back of your periodic table. You do not ever have to memorize these. Instead, you'll always have access to your periodic table whenever you need to know these. Some of the most common ones you'll see are ammonium, NH4+, carbonate, CO3 2-, phosphate, PO4 3-, so on and so forth, as seen on the back of your periodic table. You will know you have a polyatomic ion whenever your compound has more than 2 atoms in it. So for example, NaCl, that only has 2 atoms, right? A sodium and a chlorine. Even BaCl2, that still only has 2 types of atoms in it. It has barium and it has chlorine. But something like Na2SO4 has multiple atom types. It has a sodium, it has a sulfur, and it has an oxygen. So there are many, this is polyatomic. Another hint, most polyatomics usually end in ate or ite. Most polyatomics are negative or anions, but there are some cations like ammonium, for example, as NH4+. And sometimes you'll see the prefixes hypo or hyper on a polyatomic, which refer to how many oxygens are in your ion. So these are all clues about how you'll know you're working with a polyatomic ion. When you name these, the good news is the polyatomics keep their names exactly as written. You do not change the ending or add prefixes. When you write formulas, you treat the polyatomic like it's a single atom and put it in parentheses for the crossover method. So remember, before we get started, polyatomic ions are when covalent things act like ions. You put parentheses around the ion whenever you distribute an amount to the ion, and you do not distribute them. So Ca3PO42 would not be simplified into Ca3P2O8. You're not going to distribute this 2 to the oxygen and the phosphorus, even though that is technically what's going on at the molecular level. So let's practice a few. Aluminum nitrate is our first. I know it's a polyatomic because it ends in 8. Aluminum is Al +3, and nitrate, if I find on the back of my periodic table, if I look for nitrate and I find its formula, is NO3 -1. So I have a polyatomic here. And I'm just going to treat that NO3 like it is one single atom. So when I do the crossover method, my aluminum gets the charge of nitrate. So I have 1 aluminum. And my nitrate gets the charge of aluminum, which is 3. So I have 1 Al. and 3 NO3s. I'm going to treat that NO3 like it's one atom by putting it in parentheses. Here, let's do another one just like that. Here I have copper 2 sulfate. Let's skip to this one right here. Copper 2 is Cu plus 2. Sulfate, which I'll find on the back of my periodic table, is SO4 minus 2. So when I do the crossover method, again, I'm going to keep my SO4 in parentheses and cross over from there. I get CuSO4 because I'm going to simplify the 2 and the 2 cancel out, and I just write it. Most of the time, people don't put it in parentheses if there's just one, but sometimes they do, and that's okay when they do. But don't get nervous when they don't. Next, we have, let's try going the other way. We have CaOH2. What I want to do is find where OH is on the back of my periodic table and see what its name is. I find OH, and it's OH minus particularly, and it's called hydroxide. Since it's bonded to calcium, I'm going to keep its name exactly the same and just write that this is calcium hydroxide. Next, AgNO3. I want to find NO3 on the periodic table. I find NO3 1 minus is called nitrate. So when it's bonded to silver, it's called silver nitrate. Next, another one where I'm going from name to formula. This time I have 2 polyatomics, ammonium and phosphate. Ammonium is NH4 plus 1. Phosphate is PO4 minus 3. So if I keep each of these polyatomics as a single atom, and I do the crossover method, I will get that I have 3 ammoniums and 1 phosphate. Again, this doesn't have to be in parentheses, but it can be. I usually don't write it because that's what most chemists do, I would say. Lastly, we have one more. We have NH4Cl. My polyatomic is NH4, so I'm going to find it. NH4 is ammonium, and it's bonded to chlorine, so I'm going to call this ammonium chloride. You'll notice I do change the ending of chlorine because it's not a polyatomic. The only things that stay the same are our polyatomics. Like we didn't change the name of nitrate, hydroxide, sulfate, nitrate, phosphate, or ammonium. We kept those the same. The remainder of these can be found in your packet. A good idea would be to go to Activity 9 and practice a few. I'll do one more along with y'all just to make sure we are good. A big important thing is to make sure you are not overcomplicating these. When you see something like NaCl, this doesn't have any transition metals. It also doesn't have any polyatomics, so I don't need to do anything fancy with it. I can just call it sodium chloride. I don't need to call it sodium 1 chloride or sodium chlorate or something. I can keep it simple. When I do have something that has a polyatomic or a transition metal, I need to follow my rules. So let's look at number 18 in Activity 9. Number 18, we have CaOH2. OH being my polyatomic ion, which I find on the back of my periodic table, is hydroxide. It's bonded to calcium, so this is going to be calcium hydroxide. I see now that we actually already did that one, so hopefully now that we've done it twice, you really get it. It's a good idea to finish all of Activity 9 now because we have all the tools we need to name anything on Activity 9 using our 3 different types of ionic naming. Good luck.